Hi everyone. Today I am going to solve previous year's questions in potentiometer. If you want clarity in theory, you can go through the link that I provided in the description. Let us see first question. In a potentiometer experiment, it is found that no current passes through the galvanometer when the terminals of the cell are connected across 52 centimeters of the potentiometer wire. If the cell is shunted by a resistance of 5 ohm, a balance is found when the cell is connected across 40 centimeters of the wire. Find the internal resistance of the cell. Right. That means he gave balance length for the cell case as 52 centimeters. He gave balance length for the shunted cell case as 40 centimeters. He gave shunt resistance value as 5 ohm. Right. He is asking us to find internal resistance of the cell. Right. The potentiometer circuit for the cell case can be drawn like this. Right. It consists of long wire AB of uniform cross section in series with battery E0 and rheostat R0, which is kept at suitable position so that a constant current I0 flows through the main circuit. This ABCDA is called main circuit. Right. In the sub-circuit, cell is connected in series with the galvanometer in such a way that moving contact J is kept in contact with wire AB. Let us say cell e.m.f is E and its internal resistance is R. Right. Let us say the balance point for this case is at position 1. So here it is a balancing point. Right. We know that for this case at balance, cell e.m.f becomes equal to potential difference across junction A and position 1. So that means E becomes equal to potential difference between A and 1. Right, which is equal to I0 into RA1 from Ohm's law, where I0 is main circuit current, RA1 is resistance of the wire between junction A and moving contact position 1. So right, I0 is equal to resistance of the wire is given by rho LA1 by A dash, where rho is resistivity of the wire, LA1 is length of the wire between A and 1, A dash is its area of cross section. Here LA1 is nothing but balance length. Right. So here I0 rho A dash are constants. So let us say I0 rho by A dash as constant A. So which is equal to A into LA1. Right. That means E becomes equal to A into LA1. So let us take the equation 1. Right. Now let us consider second case. Here resistance R is connected across the cell. Right. Here you can see this circuit is closed. Let us say I dash is a current flowing through it. When we apply KVL, what we are going to get? So E minus I dash R minus I dash R is equal to 0. So that means I dash we are going to get as E by R plus R. What is the potential difference across the resistance R? So VR is equal to I dash into R from Ohm's law, which is equal to E by R plus R into R. Right. Let us say balance point for this case is at position 1 dash. Right. That is the thing. Yeah. So that means at balance, what happens? Potential difference across the cell, which is nothing but potential difference across the resistance R, becomes equal to potential difference between junction A and here junction A and moving contact position 1 dash. Right. So what is the potential difference across cell? That is VR. So VR becomes equal to potential difference across junction A and position 1 dash. So which is equal to I0 into RA1 dash. So which is equal to I0 rho LA1 dash by A dash. Here we assigned I0 rho by A dash as A. So which is equal to A into LA1 dash. Right. So what we got? But what is VR? So VR we got as you can see here. So that is ER by R plus R is equal to A into LA1 dash. So let us take this as equation 2. So when we take ratio of these two, what we are going to get? 1 by 2. Right. So we are going to get R plus R by R is equal to LA1 by LA1 dash. Right. So 1 plus R by R is equal to LA1 by LA1 dash. So when we take 1 that side, it becomes minus. So R by R is equal to LA1 minus LA1 dash. I am directly writing by LA1 dash. So when we take R that side, we are going to get multiplication. So what is the R value? You can see 5 ohm. So LA1 52, LA1 is 40. We can substitute all this into this. So 5 into 52 minus 40 by 40. So that means 5 into 12 by 40. So 4 3 ja 4 10 ja 15 by 10. So 1.5 ohm. Right. So internal resistance value is how much? 1.5 ohm. Which option satisfies? Yeah, that is the answer. Right. Let us move to next question. Yeah. In a potentiometer experiment, the balancing with a cell is at length 240 centimeters. Right. On shunting the cell with a resistance of 2 ohm, the balancing length becomes 120 centimeters. The internal resistance of the cell is right. That means he gave balancing length for cell case as 240 centimeters, shunted cell case as 120 centimeters. He gave the shunt resistance value as 2 ohm. He is asking us to find internal resistance of the cell. Right. Yeah. We know that for cell case at balance, cell e.m.f becomes equal to potential difference across the balance length. So that means E becomes equal to A into L11, which we obtained in the previous question. So right. Similarly, for shunted cell case, potential difference across the cell becomes equal to potential difference across the balance length, which is equal to ER by R plus R is equal to A into L11 dash. Right. So when we take a ratio of these two equations and when we simplify, what we are going to get? So we are going to get R as LA1 minus LA1 dash by LA1 dash. Here you can see LA1 dash is, this is balance length for the second case, is exactly half of LA1. So that we can see. So when we substitute, what we are going to get? LA1, this is LA1 by 2. So this is also LA1 by 2. So this means this becomes LA1 by 2. So this gets cancelled. What we are getting? R is equal to R. That means when the balance length becomes half, internal resistance becomes equal to, what is that? Shunt resistance value, which is nothing but 2 ohm. So this is the answer. Right. So which options are so this is the answer. Right. Let us move to next question. Yeah. The balancing length for the cell is 560 centimeters in a potentiometer experiment. When an external resistance of 10 ohm is connected in parallel to the cell, the balancing length changes by 60 centimeters. If the internal resistance of the cell is n by 10 ohm, where n is an integer, the value of n is right. That means in this he gave balance length for the cell case as 560 centimeters. He gave shunt resistance value as 10 ohm. Right. He gave change in balance length for the shunted cell case as 60 centimeters. He gave internal resistance as n by 10 ohm. Right. He is asking us to find the value of n, which is an integer. Yeah. So let us see. Yeah. So we know that for cell case at balance, cell e.m.f becomes equal to potential difference across the balance length for that case. So that is nothing but E. So E becomes equal to potential difference across the balance length A into L11. So that we obtained in the first question. Right. Yeah. Similarly, for shunted cell case, at balance, potential difference across the cell becomes equal to potential difference across the balance length for that case. So that is E into R by R plus R becomes equal to what is that? Potential difference across the balance length. In this case is A into L11 dash. Right. So let us take it as equation 1 and 2 respectively. So here we can write it as E into 1 also. E into 1 is equal to E only. Right. So when we compare these two equations, you can see here R by R plus R is going to be little lesser than 1. So when we see what happens here, LA1 dash is going to be little lesser than LA1. So LA1 dash is going to be lesser than LA1. Here he gave change 60 centimeters. Change 60 centimeters means what happens here? LA1 is going to be LA1 dash is going to be 60 centimeters lesser than LA1. That means LA1 dash is going to be 60 centimeters less means what? 500 centimeters. That's all. Right. So when we divide these two equations and simplify, what we are going to get? We are going to get R is equal to R into LA1 minus LA1 dash by LA1 dash. Right. So when we substitute this R value 10, LA1 he gave 560, LA1 dash is 500. So this is 500. So what we are going to get? 10 into 60 by 500. So here 2 zeros cancel. So this is 1.2. Here R is nothing but how much he gave us n by 20. So when we take 10 that side, what we are going to get? 1.2 into 10, n is equal to 12. So this is the answer. Right. Let us move to next question. Yeah. A potentiometer PQ is set up to compare two resistances as shown in the figure. Right. The ammeter A in the circuit reads 1 ampere when two-way key K3 is open. The balance point is at length L1 centimeter from P when two-way key K3 is plugged between 2 and 1. While the balance point is at length L2 centimeter from P when key K3 is plugged between 3 and 1. The ratio of two resistances R1 by R2 is found to be. Right. Yeah. That means when key K3 is open, he gave current in the upper circuit as 1 ampere. This is the thing. Right. And when key K3 is plugged between 2 and 1, he gave balance length as how much? L1. When key K3 is plugged between 3 and 1, he gave balance length as L2. Right? So he is asking us to find R1 by R2. Right. When key K3 is plugged between 2 and 1, what happens? Here you can see this resistance R1 gets connected to the potentiometer. That means in this case, potentiometer measures potential difference across the resistance R1. Right. At balance, what happens? Potential difference across the resistance R1 becomes equal to potential difference across the balance length for that case. So that means VR1 becomes equal to VL1. Right. What is VR1 from Ohm's law? So which is nothing but IR. I is 1 ampere. So 1 into R1. VL1 is how much? So this is A into L1. Right. So L1 is balance length for this case. Similarly, for when key K3 is plugged between 1 and 3, what happens? Now R1 as well as R2 both gets connected to the potentiometer. In this case, potentiometer measures potential difference across the R1 and R2. Right. At balance, what happens? At balance, potential difference across R1 and R2 becomes equal to potential difference across the balance length for that case. Right. So that means V R1 plus R2 becomes equal to balance length is how much? VL2 he gave. So right. So from Ohm's law, this becomes equal to 1 into R1 plus R2. So this is A into L2. Right. When we take 2 by 1, what we are going to get? R1 plus R2 by R1 is equal to L2 by L1. Right. So what we are going to get? 1 plus R2 by R1 is equal to L2 by L1. When we take 1 that side, we are going to get R2 by R1 is equal to L2 minus L1 by L1. I am directly writing. So R1 by R2 means what? Reverse of this. L1 by L2 minus R1. L1 by L2 minus L1. Which option satisfies D? This is the answer. Right. Let us move to next question. It is preferable to measure the e.m.f of a cell by potentiometer than by a voltmeter because of the following possible reasons. Right. In case of potentiometer, no current flows through the cell. Correct. So we know that for cell case, at the time of measurement, current drawn by the cell is 0. So that means this is correct one. The length of the potentiometer allows greater precision. Correct. This is also correct. Measurement by the potentiometer is weaker. We cannot say this, right? The sensitivity of the gallanometer when using a potentiometer is not relevant. No, it is relevant because higher is the sensitivity of the gallanometer, greater is the precision of the measurement. So this is also wrong. 1 and 2 are correct. Which option satisfies? C. So C is the answer. Right. So today I solved 5 previous year's questions. Thank you.